This one here is 230, and we're going to harden an ELF binary. So you make a vulnerable program. This has a buffer overflow. It's going to read 50 characters and put it in room where there's only 10 reserved. And when I did it a couple of years ago when I wrote this, it would just compile with no complaint. The more modern version of the compiler that's in my latest Debian here actually warns me. This looks bad. You're writing 50 bytes into a region of size 10. They're right. It is dangerous what you're doing. It's nice of them to tell me. We're going to do it anyway, but that's what happened. So here's the game. You run this thing, it shows you the password address, and then asks you for a password, and then you get fail. And I think you'll always get fail. If you look at the source code, here's win, and here it tests the password, but when it tests the password, it always just returns 1 and tells you it's wrong. There is no correct answer for the password at all. But you can exploit a buffer overflow and run the win function, of course. All right, so that's what now you can check this with hardening check. And I think you have to install it with dev scripts. Let's see if it's going to work here. Password. All right, there we go. Installing a bunch of junk. And when we're done, I can run a hardening check on PWD. Which is a pretty good thing to have. My goodness, look at all the work it has to do. Well, extracting, I guess it looks to me like it's compiling it from source or something. No, this is pre-compiled. It just uses a ridiculous number of libraries. Well, anyway, it's a pretty useful program. Must be a whole lot more complicated than I imagined it would be.
Curiosity question.
Yeah.
Could you use C++ instead of C?
Yes, I'm sure you can, but I don't think GCC would do it. I think you need to get another compiler. There must be a Linux version. Yeah. Good question. I've never done it, but it must be there.
No, considering that last time we had one of the projects was in C++.
Well, C++ is the natural one on Windows, and on Linux it's C. But I'm sure that it exists the other ways too. Like I just read in the news today, they just updated the Fortran compiler in LVM.
Fortran.
It's still in use, still being updated, which I think Fortran is even older than COBOL. Fortran's how I learned.
Fortran was not the language appropriate for data,
for math and science. Yeah, for math and science it was intended.
Formula,
and it was
translation, right?
Yeah, formula translation. It was one of the very first languages, like the third or fourth one ever made. You'd think it would have vanished long ago. Anyway,
but because they have to save money.
Well, apparently it's still somebody still thinks it's the best way to get something done. I don't know what. Maybe high performance computing. I'm not sure.
Yeah. No, because this idea of recycling, of optimizing what you already have implemented, in order to, it's an economic rule that they apply.
Well, it must be good for something. People are actually updating it. It was Fortran 4 when I learned it. Then it was Fortran 77. Now it's Fortran something else. People have updated this thing. No, I mean, they would have abandoned it if it wasn't good for something. There must be some reason why it's more valuable than the more modern solutions like Python or something.
No, for sure. I think my point is, perhaps that the reason may be highly likely economic more than,
Anyway, this is taking forever. Perhaps it's because I'm using ARM. But anyway, when you're done, you can run hardening check, and it will then tell you important information, like position-independent executable. That means it can be relocated in memory with address space layout randomization. Is the stack protected with a canary? Does it fortify source functions, which I think means prevent you from using things like the unprotected library functions? Read-only relocations. Another defense and immediate binding. We'll talk about these. Those are various defenses, and there's documentation here to explain what all those are. And then checksec is another utility that does a similar check. Do you have stack canaries? Do you have non-executable regions of memory? Do you have relocating read-only sections, which I think, now let's see if the documentation will tell us. I think it will. I think rel-ro, let's look at rel-ro. It's not there. All right, let's try the other one. Well, that's why. That's GCC isn't very interesting. rel-ro is over here. Okay, there. rel-ro. There we are. rel-ro asks the runtime layer to mark parts of the relocation table as read-only. Now, remember what we did before when we had the format string vulnerability, we could write to memory. So we wrote to the memory that pointed to the exit routine. That's a relocation record, and this marks those read-only. So you cannot modify them. So it stops that kind of attack. That's what RelRow does. That is a defense that's available. That's RelRow. The stack canary, as you know, puts a random value at the end of the current stack frame. So if there's a buffer overflow and you try to write to the return pointer, you will hit the canary first, and the operating system will know that the canary has been changed and stop instead of continuing to run.
What is the canary?
It's just a random value. But it stores it somewhere else. I think it stores it in like a floating point register. It knows what it should be. So it reads it. Every time it tries to return from a routine, it checks the canary first. And if the canary's been modified, it stops. It won't return because it suspects the return pointer has been corrupted. So it's pretty good. The non-executable memory marks parts of memory of RAM non-executable. And that's why I say RAM is either write or execute. That prevents you from being able to execute code you've injected. Position independent executable means you can have address space layout randomization and randomize its location. And I forget what these RR paths and run paths do. Let's see if we can figure that out. RR path. Let's try run path.
Maybe on the other one?
Yeah, maybe it's RR path. No, neither of them is here. Well, this was GCC. You know, it should be part of that. It was found here in CheckSec. Well, I don't have a CheckSec documentation. Let's find out. CheckSec, what is RR path? The AI will tell us. Okay. Relocation, read-only, and runtime path settings, which are security features. Well, part of RelRow, huh? This makes certain sections read-only. These specify directories to look for shared libraries. Oh, okay. So these will stop companion Trojans. This is something that happens in Windows. You take a directory and you make another directory with the same name in a different location. And under certain conditions, Windows will hunt for the directory and it will start in your current directory and it won't look at System32 until later. So you can make an extra copy of a directory in your current location, which might be like the downloads folder, and it will load that instead of the real library. So there must be a Linux version of that, and these paths are blocking looking in funny paths for things. So that's another good thing to know about. And here's, of course, whether you have symbols. Typically, when you compile, you remove symbols so that the compiled version does not have the names of routines or variables, which makes it more difficult for a reverse engineer to understand the code. You typically remove it just to make it smaller, but it's also considered a security measure to make reverse engineering more difficult. And this will tell you if it's compiled that way. So those are both useful things. So anyway, like I say, there are puzzles to solve, explaining what's going on here, just by learning how these things work. And that's good to know. And you'll be looking up things like this. Anyway, so I wanted to point you to that project. And I don't see any questions. I'm going to stop this recording.